Alright, so today we're going to start Chapter 9, and Chapter 9 is all about sequences and series. So a sequence is just a list of numbers with some sort of order to it. Now, of course, the most interesting sequences have some sort of pattern. And math is all about patterns, so sequences are pretty awesome. And the individual numbers are just called terms. So before we get started, I want to make sure that you tried this example 1 on your own. If you haven't tried it, you can stop the video and try it on your own and then come back and we'll go through it. So, gather round, my friends, and let me tell you about a time when people used to shake hands. I know, it's hard to believe. Ew, people touching each other. I don't know. So in this problem, we have a group of n people, and every person shakes hands with everyone else exactly once. And we're asked to figure out how many handshakes occur. So let's just start with finding the number of handshakes that occur in a group of 1, 2, 3, 4, 5, 6, and see if we can see a pattern that emerges. Now, if you just have one person, as long as we're assuming they're not shaking their own hand, which makes no sense, we're going to say that 0 handshakes occur for one person. If you have 2 people, then you can have 1 handshake. All right. Now, 3 people, it's a little more complicated, but like I suggest over here, if you draw, the people as dots, right? And then we can connect those dots with handshakes, and we'll call the lines handshakes. So let's say this is person number 1, person A maybe, and they shake hands with person B and person C. Okay. Now, if we go to person B up here, he's already shaken hands with person A, so he just needs to shake hands with person C, and then person C is already shaken hands with everybody. So there's 3 handshakes. All right, so we can go through this process again for 4 people, right? If we represent the people as dots, then and then we just want to connect every dot to every other dot, right? So I suggest doing it in a systematic way, though. Otherwise, it's easy to lose count. So let's just start here with this first person here. We could call that person A, and they're going to shake hands with all 3 of the other people. Right, so there's 3. Now we move on to person B. And person B has already shaken hands with person A, so they just have to shake hands with 2 more people, right? So we had 3, and then we have 4 and 5. And then we come around to this next person. They've shaken hands with everybody except for this last person. So we have a total of 6, all right? If you didn't keep count, right? We have a total of 6 handshakes there. Probably easier just to count. So this is n equals 3 people, and this is n equals 4 people. All right, so let's try 5 people. So let me draw 5 dots. 1, 2, 3, 4, 5. Okay, so I'm just going to connect every dot to every other dot. So there's 1, 2, 3, 4, and then 5, 6, 7, all right, and then 8, and 9, and then finally 10. So for n equals 5, we have 10 handshakes. Okay. All right, one more. 6. So it gets a little complicated, I guess, when you have a lot of dots. It's hard. It gets to be hard to keep track of everything. So for 6, let's just start with this person right here. So there's 1, 2, 3, 4, 5. Okay, we'll move around to the next person. 6, 7, 8, 9. Move around to this dot. 10, 11, 12. Move around to this dot. 13, 14. And then finally we move to the last dot here. He has only has 1 more hand to shake. All right, so that's a total of 15 handshakes. Okay, for n equals 6. All right, so we have a pattern here. We have a list of numbers, so we have a sequence, right? And they're in a different order, or they're in a definite order because, each number in the sequence corresponds to the number of people in the group. All right. Now, as you were going through this, did you find a pattern? Now, there typically, when I've done this with students, there's typically 3 different patterns that, and usually, people will notice one of these patterns, but the 3 typical patterns that people usually notice, some people will just notice, kind of if you look at what we just did, the first person has to shake hands with everyone else except themselves. So they have to shake n-1 hands, right? And then the second person has already shaken hands with the first person, so there are n-2 people left. And then so on, right? Every person has to shake one less hand because they've shaken hands with everybody else. And so until finally, you have 2, and then 1, and then the very last person actually doesn't have to shake anyone's hands because the other people have already shaken hands with that one person. So so you got one pattern that looks like this. Now these are actually called this is called a triangular number. I'm not expecting you to know this. This is just me geeking out on patterns in numbers. And this idea of triangular numbers comes from the same place that we have square numbers, right? We have cubic numbers. The Greeks loved geometry, right? So they had these patterns of numbers called figurate numbers. And a square number is called a square number because you can arrange the dots in a square, right? A cubic is a cubic because you can arrange the dots in a cube. A triangular number is just a number that you can, if you were to represent, say, these numbers or represent things with like stones or dots, you can arrange the number, say 6, into a triangle, right? 1 + 2 + 3. Right, so all of these are triangular numbers. Triangular numbers, which is interesting. I just find it interesting. Okay, that we get these triangular numbers from this handshake problem. All right, that's pattern number 1 that sometimes people will I call this pattern 1 that we'll notice. Now, another pattern that often people notice when counting up these handshakes is that there are n people in the group, right? So there's n people in the group, and each one has to shake n-1's hands, right? Because, say there are 6 people in the group, then everybody has to shake 5 hands, right? So they have to shake n-1 hands, right? Because they're shaking hands with everybody except themselves. But then that overcounts because it takes 2 people to handshake, right? So if we divide this by 2, we get the number of handshakes for a group of n people. So this is called an explicit formula because we have a formula for the nth term of a sequence explicitly. All we need to know is n, and we can calculate it explicitly. So we call this an explicit formula. Explicit formula. Okay. Now, one other pattern that people often notice, and I'm not saying that everybody knows every pattern, but usually I've given this problem to groups of students, and they often will notice one of these patterns, okay? So, but another pattern that people often notice is that, say you start with a group of 2 people, there's 1 handshake, and then that third person shows up, right? And they have to shake hands with everybody that was in the group previously, right? So there's 2 more handshakes. And then say a fourth person shows up. And so they have to shake 3 people's hands. All right. So essentially what we have is a recursive formula. So a sub n minus 1, n minus 1th term, plus n minus 1, right? Because if you started, say, with a group of 6, right, then if a 7th person shows up, that 7th person has to shake 6 hands, right? So we're just adding n minus 1 to the number of handshakes that we had previously, okay? So, and this is called a recursive formula. Now, I should say before maybe I write that, we have to have a seed value. So we have to have an initial value. So we have to say something like A1 equals 0 or something like that, right? So, and that's called the seed value. So if you have, and this is called a recursive, formula, okay, because, and in a recursive formula, the next value depends on the previous value, okay? So, and you have to have a seed. You have to have an initial value to start the sequence. So now all of these are equivalent, as you would expect. You know, you can get the same sequence using any of these patterns. Now, I think there's an interesting way to show at least well, really, it's pretty easy to show that these two are equivalent, right? Because you can kind of see that you're going to start with A1 equals 0, and then you can put in values, you know, you just increase n each time, right? A2 then is equal to A1 plus 1, right? So A2 is 1, and then you can increase n to 3. And A3 is equal to A2 plus 2, right? So then you can see how we, pattern 3 and pattern 1 you end up with the same result. It's not as easy to show how pattern 1 and pattern 2 are equivalent, but it is actually, I should say it's not as easy, but it's not too bad. So if we say, okay, let's just say if we say an is equal to n minus 1 plus n minus 2 plus, and so on, down to 2 plus 1. All right, we can take that same series, I'm going to just call it a sub n, and write it backwards. And it should be the same thing, right? 1 plus 2 plus dot 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 plus n minus 2 plus n minus 1, right? It's the same thing. We'll just write it backwards. Now, if we take those two equations and add them together, so an plus an is 2an, right? N minus 1 plus 1 is n minus 2 plus 2 is n, and so on. 2 plus n minus 2 is n. 1 plus n minus 1 is n. So essentially what we get is a string of n plus n plus n plus n plus n, right? And how many of those n's do we have? Well, it's the number of terms in the sequence, in this case n minus 1. So so we get 2a sub n is equal to n times n minus 1. All right? And if we just divide both sides by 2, I'm going to write it over here so we have plenty of room. You get a sub n is equal to n times n minus 1 over 2. So that's one way to show how we get this explicit formula from the sum of we're just adding up consecutive numbers. We get it from the triangular numbers. So there's an explicit formula for triangular numbers. All right, so then this last part is just saying, okay, now can we predict? If we have a group of 10 people or a group of 15 people or 100 people, can we predict how many handshakes there will be? So we can use any of these formulas. If it's just that the explicit formula is actually easiest to use because you can just put in n and you'll get the number out. Whereas the other ones you would have to, if you want 100 people, you have to add up, 99 plus 98 plus 97 plus 96, 95, 94, 93, 92. We have to add up all those numbers, which is a lot more work. So I'm going to use the explicit formula. So a sub 10, we're just going to plug n equals 10 into our explicit formula. So we have 10 times 9 over 2. Okay, so that gives us 45. A 15, if we just use that explicit formula, we get 15 times 14 all over 2, which is 105. And we can also find how many handshakes will occur with 100 people. So you have 100 people times 99 handshakes divided by 2 because it takes 2 people to handshake. And we get 4,950. All right. Well, I hope you enjoyed that problem. I just wanted to introduce sequences with something kind of interesting. And I just love the patterns in this problem. And I've only scratched the surface, really. I could go on, but anyway, I will meet you for the next example.